Hi, welcome to the Calculus 1 lecture series. This is the part 2 of this lecture number 7, the derivatives as a function. In the part 1, we talk about the definition of the differentiabilities and the relation for the differentiable and the continuous functions. And also, we said one of very important things from the graphing point of view, what is the relation of f of x, f prime x, and now for the second part of this lecture, we're going to take a look at a higher order of the derivatives. All right, let's go ahead and go to our lecture notes here. Okay, we stopped here from part 1 is how do we find the sketch of the graph. If you give me f prime x, how do I find f of x? Or, if you give me f of x, how do I find f prime x? It's basically, it's very good practice to make sure you fully understand the relationship, right? What is the derivative mean? Okay, so now let's take a look at the higher order of the derivatives here. What is the higher order of the derivative? That means you take a derivative more than once here, right? So with the higher order, we can say the second order. So for example, here. Okay, so we said the second derivative. Right, so we typically say the notation, we do like y with double primes, right? So first, the first derivative, we use just y prime, or you can say f of a double x here, okay? And so the second derivative, right? So second derivative really is the derivative of what? Of the first derivatives, right? Okay, so now let's take a look at what is the third derivative. So the third derivative, that means you can use this notation. You say dun dun dun, y triple, right? Or you can say f of dun dun dun, triple x here. So what is the third derivative? So the third derivative is really the derivative of the second derivatives here, right? So now we can in general define that the nth derivative. The notation we can use is this one here. You can say y equal to the nth, right? Or you can say this is f of the nth to the x here. So you take the derivative of nth times here. And then remember, so we can just use the, so if in order to find the second derivative, we need to find the first derivative. Then we use the definition of the first derivative to find the second derivatives, right? Okay, so now in here, for the higher order of the derivative, we have one very, very important application in the, the physics. In the physics, like if we find the position of the function, so the original functions here, if this is your position functions, okay, that means you are moving along a curve or lines. So the position function means after the t seconds, t minutes or whatever. So instead of use x, so typical we use what? We use t's, right? So t is the times here. So now in here we said the first derivative, the t, this is what we call is the velocity functions. That means how fast, you are, you are driving or you are running. So this is a velocity function. Then the second derivative here, this is what we call this acceleration function. So the acceleration function is really the what is the change of the velocities, right? Right, so this is what we call, so the most, we said it's a position function, velocity function is how fast you're driving. Then like if you push the, if you put your foot in the gas pedal, you go boom, and then you accelerate, right? So you're driving from 65 to 75, or you try to pass somebody's there. And very interested here, like for the third derivative of the f of t. So third derivative, like we talk about, is a change of the what? So this is a change of the acceleration. Okay, so we have a funny names here. We call this is a jerk. Okay, so basically it's kind of like it's like like you sit in the car, somebody keep pushing like a boom boom, like sometimes they push the like the they push the gas pedal and then immediately push the brake and then push the gas pedal, so it kind of jerk you around, right? So that's what it will change. We call this a change of acceleration. We call it the jerks here. Okay, so let's take a look. How do we do that? And let's take a look at number 10 here, right? So for the problem number 10, right now we say, hey, I want to find the first and the second derivative of this function. And right now, it's pretty difficult to find because we use the limit definition. That's why we go into the chapter, chapter 3 or next unit, we're going to show you several very useful the formula for take the derivative. So for this unit, we don't know those formula yet. So when we try to find the first derivative and second derivative, we need to use the limits, right? Okay, so let's take a look at the x plus. So let's use our definitions, right? So f of x plus h. Okay, so x plus h is what? So this is x plus h to the third power minus 2, the x plus h to the square plus 3, right? Okay, so now what do we do? FOIL it, right? So it's x cubed plus 3x squared h plus 3xh squared plus h cubed, right? And then minus 2 x squared plus 2xh plus h squared plus 3, right? Okay, so now use your algebra skill. This is x3 plus 3x squared h plus 3xh squared plus h cubed minus 2x squared minus 4xh minus 2h squared plus 3 here. Okay, so now you want to use the x plus h minus f of x over h is here. Okay, so now I'm just going to send. So well, I guess I can rewrite this one more time. So this is x plus 3x squared h plus 3xh squared plus h cubed minus 2x squared minus 4xh minus 2h squared plus 3. Then minus f of x, so it's minus x cubed, but be careful, minus need to carry in, so it's minus 2x squared minus 3, right? So minus need to be for each term. Then the next things here, let's try to cancel. So oh, this is good, xx cubed. And what is here? Oh yeah, this one is good, 2x squared. I can cancel this 2x squared, then 3 and the negative 3. Excellent, right? So then after I do that, I find out I have h here, h here, h here, h here, h here. Excellent. So what I can do is here, I can, so this is my h here, right? So I can factor the h out. So here, this is h. So this is 3x squared plus 3xh plus h squared minus 4x and minus 2h's, right? So I can factor the h out and have here, and hey, that's good, the h and cancel out. So now I have a limit h approach to 0. So this is f of x plus h minus f of x, and this is h. So it will be the limit h approach to 0. So this is 3x squared plus 3xh plus h squared minus 4x minus 2h. And I know here for h equal to 0, this term disappear, this term disappear. Okay, so I'm not careful. So this is 4x here. All right, this is 4x. And this is 2h here. This is disappear. So what is my final answers here? So final answers here, it will be what? 3x squared minus 4x. Right, so what is this ones here? This is what? This is my first derivatives, right? F prime x. You say, oh my gosh, that is a lot of algebra. That's true, right? So now, and that's why in the next units, we're going to show you some very easy formula. And you can get those derivatives very easily. But right now, we don't know that yet. So we have to use our definitions here. Okay, so now this is f prime x. We know that. Okay, now let's do the same way here. Let's do the f prime, double prime x here. Remember, f double prime x is the derivative for what? It's the derivative for f prime x. So I will do f prime x plus h. All right. So let me say you put the x plus h here. So this is x plus h to the square minus 4x plus h. Correct? Okay, simplify it, FOIL it. So this is 3. This is x squared plus 2xh plus h squared minus 4x minus 4h here. Okay, now I do f prime x here, right? So now I will do the same thing. So, okay, so here I will do the f prime x plus h minus f prime x then over h. Let's see what do we have here. So f prime x plus h is here. So this is 3x squared plus 6xh plus 3h squared minus 4x minus 4h, then minus f prime x. So it's a minus 3x squared, minus minus is positive 4x, and h is here. Okay, so now let's take a look at anything we can cancel. Okay, 3x squared. Oh, that's good. 3x squared, I can cancel 4x here, 4x here. Good. Then after that, let's see, do I have h? So here's h, there's h, and there's h here. Okay, so I can factor the h out and cancel that, right? So here, let's, oops, here. Okay, so here, so this is the, I can do here, this is h, I can get the h factored out. So this one is 6x plus 3h minus 4. Good, right? So then now I can say h cancel. Good job here. All right, so now I can do this. Okay, so now I will say that find the limit h approach to 0. Then this is h, this is f prime x plus h minus f prime x, right? So basically, I'm just find the what? I'm just find the limit h approach to 0. Then here, this is 6x plus 3h minus 4. So when the h approaches to 0, what happened to here? This term become to 0, right? Okay, so that's good. So what is my final answer? My final answer will be the 6x minus 4. Wow, good. So this is what? So this is my what? So this will be my f double prime x, right? Okay, so this will be my f double prime x. Wow, as you can see here, it takes a lot of algebra. That's why we cannot wait to go to the next unit so we can have some easy formulas here. Okay, now let's take a look here. We're going to use these relations we just defined. So let's say here, let's say number 11, let's say a particle move along an axis in such a way, time x the particle, this is my what? So this is my position functions, right? So this is the time, this is my position functions here. Okay, so let's say find the velocity and the acceleration when the time is 3 seconds or 3 minutes, they did not say. Then they ask you, is the particle moving left or the right? Is the particle speeding up or slow down? Okay, so from the previous one, we got f prime x. If we did such a tedious algebra, we get 3x minus 4x. So we found the previous problem is 3x minus 4x, right? So remember, if this is a position function, so what is f prime x? F prime x is what? F prime x is, this is the velocity. Okay, so now we said x equal to 3, so I said x equal to 3. So this will be 3, plug the 3 is 27 minus 12, so this is 15, right? So this is 15 minutes, and let's say the 15 meters per second. Let's say this S here. Okay, so now let's take a look at f double prime x here. We have the f double prime x is 6x minus 4. So we know the double prime x is acceleration. Right, so let's say the f double prime 3 is 18 minus 4, so it's 14. So this will be the 14 minutes per second square. So this is our acceleration. Okay, so now they said is a particle moving right or right? So the particle, so this is the velocities, right? So the velocity is a positive. That means what? That means I'm driving at 15 miles per second because f prime x is greater than 0. That means I'm moving right. So here, this is the positive velocity because the velocity does have the direction. And then they ask is I'm speeding up or I'm slowing down, right? So this is the f double prime x. So we know the accelerations, right? So the acceleration, so this is f double prime x, right? Also is greater than 0. So acceleration is, that means you're speeding up. So if it's a positive, so you're speeding up. So I know I am speeding up. My particle here is speeding up. See? So this is a good application for the, for higher order of the derivative. So remember, right? So the first derivative is what? Is the velocities, right? It's very, very important. We have a lot of applications here. The first is velocity, then the second derivative is what? Second derivative is what? Accelerations here. All right, that is the key part for this higher order of the derivative. Okay, so now let's take a look at this. Is another very good one. Try to decide, they give us to see how good we understand the graphs here, right? Okay, so now they said, hey, use this f of x graph, right? Try to do the f double prime x. Use your best ideas here. So it's A, B, C, D, E, G. So this is A, B, C, D, A, B, C, D, E. Okay, so the first, in order to get the second derivative, I need to find the first derivative. So this graph here is y prime, all right? So I need to get a y prime. Okay, look again. So here, okay, so here this is the terms, right? So this is a term, this is the term. So I know because this is a term at the C's, right? So that means my graph has to be touched here because this is the graph, this is the horizontal tangent line, right? So my graph has to be touch zeros here. Am I right? Okay. Okay, so now you take a look here, right? So now how do you do the other? So take a look here. So those are the tangent lines here. So if you go to tangent line, so here, this one's here, right? So at the left-hand side of the C, all your tangent line go kind of like this way, right? All your tangent lines go up. So what is the slope? It's a positive. Am I right? All right. So then after that, if you take a look at the right-hand side of the tangent line, it's go like this, right? So it's going down. So this is the negative slope, but the slope is still going negative after past D, but it's kind of smoothed out, right? So that's why I know, that means is negative is getting smoothed out. So here, this is how I know. So I know my graph of f prime here, should be something like this. After I pass it, my slope going become negative. Okay, so become steep and steep, and then like later they turn at D is going to smooth it out again. And finally, at touch the E is going to be 0. And then in here, what happens here? Hey, your tangent line become what? Become a positive again, right? So that's why I know probably this will be my f prime x. Okay, it's a very important concept like we did from the previous lectures, right? So now I'm going to take a look the f double prime x. All right, so this is what we call this f double prime x, right? Let's see, how do we do that? All right, so this will be, let's see here. This will be A, B, C, D, E. All right, E, G, H here. Of course, it's not necessary to be here because we don't have the true function, but instead use your best knowledge here. Okay, now here, I know this curve, so probably remember f double prime is the derivative of f primes here. So I know in here at D, I'm going to have a turning point. That means my f double prime here has to be 0. Correct? Okay, now you take a look in here. Okay, so on the left-hand side of your curve here, what happens here? You see here, what is the tangent lines here? The tangent line go to slope is what? The slope is negative. Then start out very, very steep, and then gradually flatten out, become 0, right? Then after you pass 0, what happened to your tangent lines here? Your tangent line become positive, right? You become positive, become and more positive. Okay, so now I'm thinking, so this is what it could be. On the left-hand side, I'm have a negative slope, but then it's gradually, it's become flatter and flatter. And then after past D, my slope will become positive. So this probably will be my f double primes here, right? So this is f double prime. So in order to do the f double prime, you need to look at the f primes here. Like I said, if you can understand those graphs, then I think you have a pretty good ideas about the definition of the derivative. Okay, so summary about this video, we talk about two concepts. One is the higher order derivatives, and make sure we understand the application part, right? So from the physics, the original is a position function, and the first derivative will be velocity, second derivative will be acceleration. And then in order to find the second derivative, remember the second derivative is the derivative of the first derivative, right? So that's why this graph is showing you how do you kind of determine what is the graph of the second derivative looks like. Okay, that's it. And we finish this unit, and I cannot wait to go to our next unit. And then we have the formula, and then we don't need to do these limits things. Again, it's very, very tedious algebra works, right? All right, that's it. And have a good day. And I will talk to you in our next brand new unit here. Okay, bye-bye.